Hello everyone, my name is Shiao. I'm very happy to present our work, Confirmation Bias, the Double-Edged Sword of Data Facts in Visual Data Communication. So firstly, what is confirmation bias?
Confirmation bias is the phenomenon where people tend to search for, interpret new information as confirmation of one's existing belief or theories.
So why shall we care about this bias? Confirmation bias can make us researchers only cite favorite theories that support our hypotheses and findings. Confirmation bias can also induce more polarization on social media platforms. In criminal cases, confirmation bias can even make authorities only looking at evidence proving someone is guilty or not, and lead to false investigation and prosecution. And we believe that confirmation bias also impacts visualization. For instance, here we have a small multiple bar chart where x-axis depicts different vaccination status and y-axis depicts the mortality rate. Each row depicts different date from May 21st to May 25th. People with different prior belief might emphasize on different patterns. For instance, from the same visualization depicting the correlation between vaccination status and mortality rate, people who think vaccination should not be mandatory might pay more attention to a positive correlation between fuller vaccination status and mortality rate, while people on the other side might pay more attention to such a correlation in a negative direction. To help people explore complex visualization more efficiently, data facts, which is the statistical summary of visualization, are often used to help users synthesize visual trends. However, scenarios could be more complex when people's prior belief interacting with data facts, especially when it supports prior belief, and it will lead user to partial decision-making processes without inspecting visual trends that contradict their prior beliefs. Therefore, in this work, we investigate how the presence of data facts might impact the manifestation of confirmation bias while humans are reasoning with visualizations. Let's experience the experiment. Through a preliminary study, we designed an ambiguous small multiples bar chart. In this bar chart, we have equal numbers of rows depicting either positive or negative correlation between the row and column variables, and make participants not able to draw a concrete conclusion about whether the majority of visualization is depict a positive or negative relationship. We measure confirmation bias by asking our participants to evaluate to what extent the visualization support a given prior belief. Since we expect participants read the visualization as 0 if they are fully expecting the visualization, we interpret deviation from neutral towards the supporting evidence as the magnitude of confirmation bias. Our resultant bias score ranges from -100 to 100. To understand how we interpret bias score, let's imagine if David has a prior belief that vaccination should be mandatory. While a bias score of 0 indicates David perceived ambiguous visualization as a neutral evidence, and 100 when David rates visualization as strongly supporting his prior belief as vaccination decreasing the mortality rate, and -100 when David rates visualization as strongly refuting one as he pays more attention to the positive correlation even though he believes vaccination should be mandatory. We take the impact of human prior belief on the exhibit bias into consideration as well. Therefore, we assign two different datasets to the ambiguous visualization. The first one is about vaccination mandatory policy, where we expect to be polarizing and people tend to have stronger beliefs. The other one is about diet choices, where we expect to be more neutral and people tend to have a weaker prior beliefs. To evaluate participants' prior belief before they inspecting the visualization, we measure the strength of these beliefs by asking them, how strongly do you agree with vaccination being a mandatory policy for the vaccination topic? And plant-based diet is healthier than diet including meats for the other topic. To investigate the impact of data facts on bias, We firstly explore how different alignment of data facts might impact confirmation bias. We recruited 1,080 participants. For each of them, we let the participant rate two different ambiguous visualizations, one with data facts supporting their prior belief, and one with a refuting data fact. We also further investigate how would different presentation style of data facts impact the exacerbation of confirmation bias. We split our participants into three groups. They either see two visualizations with data facts plus visual annotation to reflect the traits described in the data facts, or two visualizations with data facts only, or visualization with no data facts and annotations. We finally consider the content of data facts. For instance, a more compelling data facts that directly describe the correlation between row and column might lead people to be more biased, compared with the data facts only depicting average value of a given column. To summarize, in each study trial, within the two visualizations participants reason with, one will be a visualization with more compelling correlation data facts, and the other one will be with derived value data facts. The order of the alignment and the presentation style of data facts were also counterbalanced. After obtaining our experiment data, we firstly ask questions regarding the impact of human factors. How does the strength of human prior belief impact the manifestation of confirmation bias? From our experiment, we identified the strength of the prior belief as a strong predictor of confirmation bias. We identified the strength of prior belief is positively correlated with the effect of confirmation bias. While we did not observe any differences between topics, after exploring the impact from human factors, we now transit to our observations regarding data facts design choices. We first look at the alignment of data facts. Let's bring back David, who believed vaccination being mandatory back to our discussion. When the data fact supports David's prior beliefs, we found it will lead David to be more biased compared with scenarios without any data facts. While when it refutes David's prior belief, we found data facts make David less biased. We next look at the presentation style of data facts. When the visualization is paired with the data fact supporting David's prior beliefs, adding a visual annotation could further exacerbate the effect of promoting David's bias level compared with when there is no data facts. Well, we did not find such a difference when data facts refuse prior beliefs. Finally, we observed that visualization with stronger type of data facts has stronger power to shape David's interpretation of visualization the same as the data facts content. When the data fact supports prior belief, the stronger data facts correlation make David more biased compared with no data facts. While when data facts refuse prior belief, the stronger data facts correlation make David less biased compared with no data facts. Through our experiment results, you might also wonder, did we observe real confirmation bias or people just echo back to data facts? To answer this question, we went back to our results on data facts alignment, focusing on the exact bias scores collected from our experiment. We observed that even though people are looking at visualization with refuting data facts, the left bound of the confidence interval for the confirmation bias level is still greater than 0, which means that participants tried to interpret a refuting evidence as a supporting one, and that indicates we observed the true confirmation bias. To summarize the main takeaway from our findings, we identified human prior as a strong predictor of the confirmation bias. Our experiment finding also revealed that data facts have the potential both to exacerbate or mitigate confirmation bias depending on their alignment directions. And incorporating visual annotations might further exacerbate these effects, especially when the data fact supports prior beliefs. We assert our findings as an opportunity to leverage the mitigation potential of data facts in future system design. For instance, if future system can leverage the belief elicitation prior showing users the data, system can display refuting data facts alongside visualizations and thereby mitigate confirmation bias in an interactive setting. This work was supported by National Science Foundation. That's all I have. Thank you for listening.